All right, I got Dr. Stephanie Seneff on the show for round two. She's a senior research scientist at the MIT Computer Science and Artificial Intelligence Laboratory and the best-selling author of Toxic Legacy, How the Weed Killer Glyphosate is Destroying Our Health and Environment. Dr. Seneff, welcome back to the show.
So great to be back. Thank you.
Yeah, really excited to have you back again. And it's funny, since your book, last time we were talking about glyphosate and just how toxic it really is. And it was so good to dive into that research that you're really the pioneer, like forethought leader in this category. Like, we're starting now to see through lawsuits and stuff that glyphosate is extremely dangerous to our health. And I remember learning a long time ago about glyphosate, and I thought, organic, not organic, it's not that big a deal. But when I read your book, I was like, wow, I have been overlooking this in my own health and thinking that it really wasn't that big a deal. And it was. It was a big deal. And even since your book was written just a few years ago, I think we're starting to see that in the forefront. So, I mean, thank you for what you've done. I think people are finally starting to see, like, no, this is a problem.
Yeah, I think they are. I feel like more and more people are waking up, and we're becoming much more aware that we are a sick nation. We have so many health problems. You know, just the obesity epidemic alone is just obvious. And what is causing this? You know, we just to say we're just lazy slobs. That's not true. We're being poisoned in such a way that we can't help getting fat. I think that's what's happening. And I think glyphosate is the primary factor in obesity, among many other diseases.
Yeah, it's creating that interference on the cell. So it's making hormones, it's making insulin, it's making everything resistant because information can't actually get into the cell. And so you're seeing resistance and hormone resistance with testosterone lowering in males. With women, we're seeing the same thing. And then again, the obesity crisis, right? And
Right.
you're seeing that insulin resistance. So true. And then also autism right now. I think what the numbers have went from like 1 in 36 to like now 1 in 3.
I don't know 1 in 3, but 136 is what I'm hearing from the CDC.
Yeah.
And it's higher than that in the newborns, you know, because that's like kids that are 10 years old.
Yeah. So crazy. I know. So I brought you back for round two because I really wanted to talk about deuterium, and it's very little talked about. There isn't a ton of people, just the same way that you pioneered to me the research in glyphosate and ringing the bell. I've been following you, and you've been ringing the bell on deuterium. Now, deuterium is something I heard about a couple of years ago. It's known as this heavy hydrogen, but nobody really talks about it. And it's not, I don't hear it talked about at all, other than a few people like yourself. And so I'm wondering, when you start talking about things, Stephanie, I'm thinking, my ears perk up. I go, wow, what's going on? What is she seeing? Why is there a correlation between high deuterium levels and glyphosate load? I don't know, but I wanted to get your opinion for people that don't even understand what deuterium is, and maybe why they should start focusing it in their health.
Yeah, deuterium is super fascinating, and I really got grabbed onto it. It was in December of 2019 that I was approached by Professor Laszlo Boros. He basically complimented me on a paper we had just published, and then he said, "Oh, by the way, deuterium," you know, introducing that topic to me, and I'm like, "Oh, I don't know anything." And it was a quick jump into it. I dove in head first because it was clear to me that the way the body manages deuterium and the way glyphosate interferes with things coincide. They coincide. So glyphosate is messing up our ability to manage deuterium properly. And if you think of iron, you know, you probably know a lot of people have iron deficiency, but people also have iron overload. You know, the iron becomes toxic to them. These metals, many of these metals, the minerals that are essential for our health, are also toxic. And so we have to get the balance right. And the thing is, your body has to be able to hand carry these things to the right place and deliver it where it is needed, and then keep it away from places where it's going to cause damage. And that's the same with iron as with deuterium. The body needs to know how to handle it, and the body does know how to handle it. It handles it very, very well, except that so many of those enzymes and proteins that are involved in deuterium management are harmed by glyphosate. So this is why I got really interested, because I could see very clearly right away how they would connect up. And then I just started reading everything I could and really getting deep into metabolism, because it turns out deuterium, the gut microbes, help us a lot. They are essential. They play an essential role in helping us to steer deuterium into the right places and keep it away from where it shouldn't be. And then glyphosate wrecks the gut microbes, and then you start from there. And the thing that gets hurt the most is the mitochondria. So it's a mitochondrial disease that you'll see with chronic glyphosate poisoning because of glyphosate. I think primarily because of glyphosate disrupting deuterium homeostasis. That's kind of the short answer.
Yeah. Yeah. So for people that don't, and there's a lot of science, and you've done, I know, a lot. If anybody just looks online, they can actually see you've got tons of presentations recently on deuterium. You can kind of walk through. But if someone's just listening to us and they're like, okay, I don't even know what deuterium is, how would you describe it? Because the way I always look at it is I know it's described as a heavy hydrogen. The way I always think about it, it's like this sludge or something that builds up in the cell, and it makes everything in the body just move slower. And the way I've kind of learned about it is if you deplete deuterium, if you lessen your deuterium load, ATP, the mitochondria, everything runs better. Is that a good way to think about it?
That's a good thing. I think the ATPase pumps are the main factor that's very sensitive to too much deuterium. That's where you get in trouble if there's too much deuterium running through those pumps. Those pumps are really interesting. They're in the mitochondria. The mitochondria make the energy, they make the ATP. ATP is the primary energy source of the cell. So very, very important. And glyphosate's been shown in multiple studies to disrupt the mitochondria, to particularly harm the mitochondria, in terms of causing them to release more reactive oxygen species and to not be able to as efficient in making ATP. So this is a critical thing with mitochondria. When they get sick, they release these partially, because they're trying to turn oxygen into water, but they kind of get part way, but they don't finish the job. So you end up with these reactive oxygen, that's ROS, they call them. Those are going to cause things like cancer because they're going to cause DNA mutations, and they're going to harm the fats in the cell. They're just going to cause quite a mess if there's too many of them. And the mitochondria are the main source of these problems in the cell. So the mitochondria want to run really smoothly. And to do that, they don't want to see deuterium. Deuterium is like sugar in the gas tank to the mitochondria.
Yeah. Yeah. How, what is your research? Why have you become so fascinated? Obviously, because of this, we're seeing this connection, but I'm curious. I mean, usually with fascination is I'm also wondering, have you seen through studies that you've researched or all the research you've done, or even anecdotally, I'm sure now I know you're drinking deuterium depleted water and you've got people like me who follow you. Maybe there's people that are saying, hey, Stephanie, look I started doing this and I'm feeling better. What have you seen just from the research, either like cancer or anything? Have you seen any just positive outcomes by people lessening their deuterium load and changing nothing else?
Well, there's this guy Somlyi, I believe. Somlyi, I don't know how to say it. It's kind of a hard name to pronounce. He's been really passionate about deuterium for a long time. He's written 2 books. I read his second book on his studies on cancer patients. And so what he does is he just provides the cancer patients with deuterium depleted water, and they can even
What's
just
the book
add.
called, Dr. Seneff?
Pardon?
Well, do you remember what the book's called?
Oh, I have it somewhere here. No, I'm sorry, I don't.
I'll go
But
back.
his
To the
name
show
is pretty
notes.
unique. Somlyi. If you type Somlyi deuterium into Amazon, you'll probably find both of his books.
Okay. Perfect.
And his books are not particularly entertaining. They're like dry stories of patient after patient and what kind of outcomes they had. And generally, what he shows is that and he's got papers as well. I've been reading his papers. His general message is that when you have cancer, if you seriously take deuterium depleted water, you live longer. So there's always just this life expectancy given that you have some kind of terminal cancer. And his patients beat out most people. They live longer then. It's not like it cures the cancer. I mean, I think it's very rare, although some of them have actually lived for decades. In this book, he talked about patients who just completely seems like the cancer disappeared. So I think it's possible for it to completely reverse the cancer, but it definitely gives people longer lifespan. And of course, it also doesn't have symptoms. I'm not aware of any side effects I mean, maybe if you overdo it, you could have some side effects, but if you drinking modestly deuterium depleted water, I think it's not going to have side effects. And so that's a really nice thing about it. And his patients often go ahead with their regular treatment as well. So it's sort of, it's complicated to say exactly what helped them and what didn't, that sort of thing. It's very hard to, as you know, it takes a lot of money to do a proper sort of controlled study and all this kind of stuff. And most people who aren't in the drug companies don't have that kind of money to spend. And so it's harder to prove that something is working. But statistically, the odds are pretty amazing as far as his patients when he gives them the deuterium depleted water. And some of them will sort of stop doing deuterium depleted water, and then their cancer will come back, that kind of thing. So it's all anecdotal. Most of it's anecdotal, but he has statistical significance showing up in some of his papers.
Is anybody doing deuterium research across the world, like Japan, or are we seeing anybody that's kind of taken it by the storm?
Well, deuterium, the whole concept of deuterium being important came out of Russia, actually. Russia was where it all started. The Russians scientists were interested in these people who lived up in Siberia, and they had pretty bad food. You know, they didn't have a whole lot of healthy fruits and vegetables because they were way up north. So they ate a lot of animal fats and things like that. But they also drank water that came off the glacier, and that water was significantly depleted in deuterium compared to, say, seawater. Deuterium is a natural element. It's everywhere in the world, and it can be higher concentrations in water or lower depending upon where that water comes from. And when you melt water off the glacier, the deuterium always tends to stay behind in the more solid form. So from ice to water, you get less deuterium in the water. From gelled water to non-gelled water, you get less deuterium in the non-gelled water. From water to gas, you get less deuterium in the hydrogen gas than you do in the hydrogen that's in the water. So all of this kind of distillation process can end up with less deuterium. And that's actually really critical with respect to the gut microbes. I'll get to that in a moment, but very interesting science. But the Russians figured out that these people, they were living until over 100, and they were very healthy right up to the end, you know. So they were curious as to why they were so healthy. And eventually scientists attributed it to their water supply, the fact that their water was consistently, I think glacier water is like maybe 100 parts per million or 110 parts per million instead of 155 parts per million, which is what's in seawater. That's kind of the norm, 155 parts per million.
Yeah. Okay. Interesting. Yeah. And I know the guys at Light Water, we'll talk about them a little bit later. It's LITE water. They make depleted deuterium, but they're also, you just mentioned seawater minerals. They talk a lot about that. They have their own products for that they're very bullish on, as well as hydrogen water, which I'd love to talk to you also about. But you mentioned gut health. And speaking of gut health, I know it's very important that having these hydrogens and having hydrogens being created, it's actually a good thing. What were you gonna say about deuterium?
Let's get to that, because that's extremely important. I think it's central, and it's so fascinating. And I mean, you know that people often have gas, you know, they're getting kind of bloated, and that gas is methane, for one thing. They talk a lot about methane, the cows making too much methane, global climate change, all that. Methane is an important gas that's produced by the gut microbes, but also hydrogen gas and hydrogen sulfide gas. All these gases are produced by the microbes. And the hydrogen gas turns out to be extremely important, I believe. And it's really fun because I found a paper that was published in the 1960s about microbes. They had a microbe, they were studying them, and they were particularly interested in finding out how much deuterium there was. I don't know what gave them the idea to do this study. How much deuterium is there in the gas, the hydrogen gas that's produced by the microbes, compared to what there would be in regular water? And they found that it was 80% down. So in other words, 80% of the deuterium was removed by the process of making hydrogen gas, coming out of the hydrogen that was in the original molecules in the water. So basically you can take glucose, sugar, and you can extract hydrogens from the sugar. If you're a microbe, you could do this and make a gas, H2, you know, two hydrogen atoms, put them together, make a gas. The microbes do this. They do it a lot. They make the hydrogen gas. And when they do that, they lose 80% of the deuterium. This is, I think, absolutely central to the deuterium story, I believe.
Wow.
I have only that one paper, so I'm sort of hanging onto a thread. I can't find anything else. It's really frustrating. But that paper is a lot better than having nothing, right? So it's 20% of the amount of deuterium in the hydrogen gas compared to what was left behind in the water. So whenever they make the hydrogen gas, they kind of leave deuterium behind in the water, is the point, you know? So they're able to build, to make a form of hydrogen that's extremely depleted in deuterium. And then they don't just throw that gas away. They actually use the hydrogen gas to make methane from carbon dioxide. So the methane that, you know, is supposedly causing global climate change, that's got low deuterium because it comes from that hydrogen gas. CH4 is methane, 1 carbon and 4 hydrogens. And those 4 hydrogens came from that hydrogen gas. So that means the methane is also 80% depleted in deuterium. And that methane is not thrown away. Normally, the microbes take that methane and turn it into methanol, which is a very toxic alcohol. You have ethanol, which is the one we drink, and then methanol, which is a very short, very tiny alcohol. Um, and methanol, it comes from methane. Through the gut microbes, they make methane, they make methanol, then they make formaldehyde, which is also pretty dangerous. It's like a carcinogen. And then they make formate. And then from the formate, they go back and make hydrogen gas and carbon dioxide. So they basically have this cycle around and around, and it's a distillation process. And along the way, when in making all those steps, they're dumping hydrogen into NAD plus. So they turn NAD plus into NADH. And NADH is pure gold. NADH is the molecule that delivers hydrogen to the mitochondria. There's this NADH dehydrogenase enzyme in the mitochondria that takes the H off and puts it into the intramembrane space in the mitochondria, piling it up so that it can go through the ATPase pump. So in other words, NADH is the molecule that delivers hydrogen to the mitochondria. The hydrogen is what powers the pump to make the ATP. You push protons into this inner space. You get them crowded in there, and then they want to come out, and they come out through the ATPase pumps. So they're driving the motor. It's kind of like making a water wheel. They drive the motor that makes the pump, gives it the energy it needs to make the ATP. Fascinating biophysics there, but those pumps are very delicate, and they use the hydrogen. The hydrogen goes through very nicely, but the deuterium is twice as big because it's got this extra neutron. So when it goes into the pump, it kind of gets stuck. It's like it's too big and bulky, and it also binds more strongly to things. So it just doesn't like to get through smoothly. And so the body tries to minimize the number of deuterium atoms that make their way into that pump. And it does so through NADH. And NADH can get its H essentially from methane, which is from hydrogen gas. If you trace that through, if it gets its H from hydrogen gas, it's going to be low in deuterium. And so the whole point is to have the microbes make as much NADH as they can to supply the mitochondria for the host with low deuterium protons. Does that make sense? I know it's a little bit techy,
but a lot. I'm just thinking too, as you're speaking, because NAD right now is all the rage. Everyone's taking NAD for more energy. What you said, ATP, better efficiency in cells, anti-aging, longevity, DNA repair. So I'm just wondering too if there's any connection there, or is that even is that a smart thing to be taking, or should we really be focusing on the deuterium instead of worrying about NAD or supplementing with NAD?
Well, we need to have enough NAD to do the job. And in fact, that is a problem because NAD actually is produced from tryptophan, which is a product of the shikimate pathway, which glyphosate famously disrupts. So glyphosate suppresses the microbe's ability to make the tryptophan, which is a precursor to the NAD. And so by virtue of not having enough tryptophan, then you can have a deficiency in NAD, which is real. If you don't have enough NAD, you can't make enough NADH, right? It's just like there's a shortage of the basic molecule that's carrying the hydrogen. That's a big problem. So it's true. People need to get enough NAD, and they can eat foods that are rich in tryptophan, for example.
Yeah. Wow. Talk to me about metabolic health. And you talked about it a little bit, but what is the research just showing between the relationship between deuterium and metabolic health?
Yeah, well, we could again go back to the microbes because the microbes provide short-chain fatty acids to the host, and you probably know about that. Acetate, butyrate, and propionate, those three, which are tiny little fats, right? They're short. You have the long-chain fatty acids like the arachidonic acid that is in our foods. We get a lot of arachidonic acid in our seed oils, for example. And that's something that Dr. Mercola has been on the case of arachidonic acid. I don't know if you've seen his latest, but he's really come out strong against arachidonic acid as an unhealthy food, he thinks. And that also connects to the deuterium glyphosate problem. Because I can get into that if you like right now, but we basically have a big problem with fats and with metabolizing fats because of glyphosate. And it also gets back to the gut microbes. But those short-chain fatty acids that the microbes produce are really, really important in the gut for the health of the colon. So colon cancer, you have inflammatory bowel, all these things are going up over time in step with the rise in glyphosate usage on core crops. And I think it's a direct hit. Glyphosate is causing disruption of the gut microbes, which is causing an inadequate supply of the short-chain fatty acids. And those short chain fatty acids, you can trace them right back to that hydrogen gas. So the microbes make the hydrogen gas, they make the methane. They also make acetate from the hydrogen gas out of carbon dioxide. Basic ingredients, carbon dioxide and hydrogen gas. They make acetate. And the acetate is the shortest of the short chain fatty acids. And they can use the acetate to make the butyrate as well. So then the butyrate comes from the acetate, which comes from the hydrogen gas, which means that the butyrate is very low in deuterium. And the colonocytes love butyrate. That's their favorite food. And so what happens is glyphosate's poisoning those microbes. And so they're not able to make enough butyrate. And then the colonocytes are starving because they're not getting their healthy food, which is extremely low in deuterium. So then their mitochondria are going to get sick. And then you're going to end up with cancer. So it's a pretty simple story, really, I think.
I love that. It's simple. It's easy. Okay. So here's the thing. I remember hearing a long time ago too, if there's a company out there, I think they're like called the DDS or something, like the Deuterium Depletion Scientific Research Board. They're like one of the main folks out there actually doing some of this research, and they advocate for a keto diet. And that if you want to make more deuterium, you should be on keto. They actually put people on a keto diet, and they do some lifestyle things and et cetera, et cetera. And they watch deuterium depletion, drinking the water like we were talking about, and they see people's deuterium deplete. What do you say about keto? Is that like the ultimate diet? Should we all be on keto 90% of our lives? Or like, what are your thoughts now? Because you're talking about butyrate, and that's a big thing.
Butyrate is butter, by the way. Butter is a good source of butyrate, and that's definitely a fat. So it's fascinating because the fats are synthesized basically from these acetate molecules. So if you go all the way back to the acetate, which is produced by the microbes from the hydrogen gas, that's going to be low in deuterium. And acetate, of course, is really important. Acetyl coenzyme A is like what drives the mitochondria. That's the fuel that goes into the mitochondria. Acetyl coenzyme A is acetate attached to a coenzyme A molecule. And the acetate, if it comes from that path, from the hydrogen gas, it's going to be low in deuterium. So you want the gut microbes to make a lot of acetate. That's kind of the base of everything else that'll give you the healthy deuterium depleted nutrients. And the acetate, many acetates are put together essentially to make a fat. So the fatty acids are also low in deuterium because they're assembled from those acetates. So fatty acids are a good source of low deuterium, and they've shown that experimentally. They look at butter and ghee and coconut oil; they're all low in deuterium, whereas sugar is high in deuterium. Mm-hmm. So if you're eating a high sugar diet, you're eating a high deuterium diet.
Yeah. What are your thoughts on that? Has that switched for you in terms of the way has your diet changed at all since kind of diving into this deuterium research? Have you kind of gone more into keto lately or experimented more?
I've always had a high fat diet. Actually, I've always loved butter, and I eat a lot of fats to begin with. I like to have more on the fat side rather than the carb side. Yeah. I just tend to be that way, and certainly I'm continuing to be that way. I don't completely ignore carbs, but I think my balance is more towards fats than carbs.
Yeah.
And then enough protein you don't want to eat so much protein that it becomes a source of energy. Because then you're going to have a nitrogen overload problem. So some people make the mistake of eating too much protein. They say, okay, fats are bad, carbs are bad, I'll eat protein, and then you end up having to use the protein as a source of fuel. And the nitrogen then is left over because the carbs and the fats don't have nitrogen. That's the thing that proteins have and carbs and fats don't have. And so that nitrogen kind of gets in the way if you're going to try to use it as a fuel. You have to get rid of that nitrogen somehow. But you need to eat enough protein to be able to build your own proteins. Their proteins are disassembled into amino acids and they're reassembled into your proteins. So you need to eat protein. You don't want to have a zero protein diet, but just enough really to replace, to keep your proteins going. Not so much that you have to use it as a source of energy. Yeah. Would be my rule of thumb,
Yeah. It's interesting. I do better. I mean, I've operated in my life on a more, probably in the last decade, I've been more high fat, very low carb. I do well on it. I enjoy it. I enjoy butter, like you mentioned.
Yes.
But one of my mentors, and when we're looking at the blue zones, he was telling me, Joel, keto. And if you look at and he's a very scientific, researcher. He's like, when we look long-term keto, it's not as healthy as people say. And he's like, listen, I use keto in my practice all the time. I might have people go to keto for 3 weeks, but then they come out of it, right? And he was saying, when we look at the blue zones, people supposedly that are living the longest living centenarians on the planet, the commonality there is they do eat carbs. They actually eat high carbs, but it's hypocaloric. They still have a hypocaloric diet, but they're eating high carbs. And their fat is low actually, and their protein is moderate to low. And so I struggle with that. You know, I get research like this from you, the deuterium, and then
Have you been following Mercola? Because he's jumped on that bandwagon as well. He was always like high fat is good, low carb is good, you know. And then he made a complete about face. And lately he's been saying, oh, carbs are wonderful. You need to eat more carbs. Have you noticed that?
No, I haven't.
It kind of shocked me. It's like, oh my God, this guy's gonna. It makes you very confused.
Well, I read his book many years ago, Fat is Fuel or something like that, where he was
really big on keto for a long time. And I suppose he probably was on keto for a long time. And I'd love to know, I don't know the backstory of why he changed his mind, but he obviously talks to all kinds of people and he listens to people. He's definitely curious. I respect Mercola. You know, he's a friend of mine, and I've enjoyed following his career and where he goes, because he's willing to admit, well, I was wrong. You know, he's willing to do that. Most people are not. They'll sort of stick with whatever they were saying, you know, even though they may start to see some weaknesses in it. But it's all very, very complicated. And I think that people need to be paying more attention to the toxicity, because you cannot evaluate these foods in the absence of considering what the poisons are doing. Mm-hmm. That's the problem. The poisons are interfering with our metabolism in ways that if you're going to continue to eat the poisonous food, you're going to have to be very careful, because the poisons are messing everything up. So things that would ordinarily be healthy are no longer healthy because of the toxins that we're exposed to from the chemical-based agriculture. That's what I think. And it's very interesting with respect to the fats. And I can really get into this right now because I was so excited. This is actually fairly recently. I've been studying glyphosate, as you know, for over a decade. And I go through I basically scroll through the protein databases looking for proteins that I think would be susceptible to glyphosate. I have certain patterns that I can expect. And I write about that in my book, the glyphosate susceptibility motif, you know, which is, again, a techie kind of thing, but it's a protein that has at least one glycine residue. Glycine is the smallest amino acid at a place where the protein binds phosphate. And so you can find proteins that have that pattern. And I say those proteins are going to be more susceptible to glyphosate toxicity than other proteins. And I explain in my book why that's the case, because glyphosate is a glycine molecule, but it has extra material stuck onto its nitrogen atom. And that extra material is a methylphosphonate, which looks a whole lot like phosphate. And so any protein that needs to bind phosphate at a place where there's a glycine, the glycine is there because it's small, because you have to have room for that phosphate substrate to fit into this socket that's created by the shape of the protein. But glyphosate is like, oh, I've got a great place to put my methylphosphate. I'll put it here, you know. So it's happy to just throw itself into the place where the glycine is supposed to go, because it is a glycine molecule. It matches perfectly in the assembly machinery. When the proteins are building themselves, you know, they're being built by these all these enzymes that are assembling the amino acids like paper dolls holding hands. And they have a code, you know, it's a famous DNA code. And you see the code for glycine. You grab glyphosate and put it in there by mistake because it looks like glycine. And the methylphosphonate goes into the spot where the phosphate's supposed to bind. Now the phosphate can't bind. The protein's wrecked. It can't do its job. And that's exactly what goes on with EPSP synthase. That's the enzyme that it famously disrupts in the plants that kills the plants. It's exactly that model. It's a site where glycine is highly conserved. If you replace that glycine with alanine, the protein is completely insensitive to glyphosate. So it's the code that matters. Does that make sense to you? That might be a little too techy.
Well, that's what you were also talking about. I remember in the book, you were talking about how glycine, that amino acid, is getting disrupted from glyphosate. And that's why we're seeing such a breakdown in connective tissue, collagen synthesis.
Exactly. Collagen has tons of glycine, which makes it very susceptible. And the glycine is critical for the collagen to form its beautiful crystal structure, which is this triple helix structure, which is what gives it's all its unique properties. The collagen is it's the most common molecule, most common protein in the body by far. Like a third of our proteins are collagen molecules. They have a whole long sequence of GXY, GXY, GXY. Every third amino acid is glycine. They've got tremendous opportunity for glyphosate mischief.
Yeah, and that's what we're going to see, an uptick in athletes and young athletes, kids too, and their connective tissue and injuries because that connective tissue is damaged because the glycine molecule can't bond, correct, from what you're talking about.
Yeah, it's replacing the glycine and then it's making the collagen so it can't form the proper structure. And it's like a mutation. You can get a mutation in one glycine in collagen, you can have a very pretty serious disease just from one glycine being incorrect. The code got broken,
Yep.
a genetic change. So glyphosate going in there is the same effect, but it's just going to attack one collagen molecule at a time.
Yep.
If you have the mutation, all your collagen molecules will be screwed up, So.
Well, and the thing about that too is, and I know you know this, a lot of the collagen powders out there that people are trying to supplement their collagen with, they're filled with glyphosate. They're
Exactly.
filled with toxins. So you're not even if you're supplementing it, you're getting a glyphosate. They've tested a lot of these, major companies out there that at Costco and all the places you go to buy collagen powder, they are tainted with glyphosate.
Yeah, Anthony Samsel actually tested. He got a bone, cow's bone from a butcher, from a CAFO cow, a confined animal feeding operation cow, and he tested the bone and found pretty high levels of glyphosate in the bone. I mean, bone has a lot of collagen.
Yeah. Stephanie, talk about, people are listening like, okay, wow, she's made a great case, an argument that, deuterium is a problem. It is this sludge. It creates disease long-term and mitochondrial dysfunction, which we know that increases aging. And when the mitochondria goes awry, we see an uptick in cancer and things like that. Talk about what people can do proactively then to lower their deuterium levels. What are some things that either supplements or lifestyle things that maybe they could embark on?
Well, you certainly can get deuterium depleted water. You can buy that on the web. It's expensive. It kind of seems ridiculously expensive for water. And I tend to be pretty tight, with money, and I drink it. So it just kind of shows you my own perception that I think it's important enough to go ahead and buy it. But I only have a little bit every day. I just use a third of a cup.
Dr. Seneff, by the way, have you tested yourself? Have you tested yourself prior to doing
I tested my saliva before I started, and I think it was right at the mark with the seawater, 155 parts per million.
Okay.
So
and now since you've been doing how long have you been doing deuterium?
I haven't tested again, but I've been doing it for quite a while, for probably a couple of years. Steadily every day, a third of a cup. But it's you buy this stuff that's extremely low in deuterium, only 10 parts per million, which you don't want to drink that straight, because that's not natural either. You want to keep in that natural range. So it's interesting. They have to sell it with less. The less, the better, right? So 10 parts per million is what you buy, and then you mix it with other water to make it more like glacier water. So you're trying to shoot for something like 90 parts per million is what I try to shoot for. So I just do the 1/3 cup, 2/3 cup of regular water is how I mix it. Then I just drink a cup of that water every day.
That's the regular water you drink, is it distilled or reverse osmosis? What do you usually do?
Yeah, it's filtered water, but that's all. I don't, not distilled.
Okay.
That's what I do.
That's option number one. You can go to, I know Lightwater is probably the number one company out there that's selling.
That's what I buy, Lightwater.
Yeah.
And I've been happy with them. So that's worked out. But the other thing is organic diet. I think it's the most important thing. Switch to a certified organic diet. That'll help you to significantly reduce your glyphosate exposure, because I think glyphosate is really the problem, not deuterium, but glyphosate. And actually, I should say that deuterium is not all bad. Just like iron can be toxic, but it can also be deficient. Deuterium can also be deficient because your bones actually concentrate deuterium. It's really interesting. Your body tries to trap the deuterium outside the cells. And in fact, I think the gelled water that lines the blood vessels traps deuterium. So Gerald Pollack talks a lot about gelled water. You're probably familiar with his work.
Yeah, fourth
and
phase
how the gel
water
creates a battery and pushes the protons out. And so the gel becomes negatively charged, right? And it's pushing the protons out. So if you think of the gel lining the blood vessels and then pushing the protons out into the circulating blood, right? So because deuterium stays in the heavier state, it stays behind. It tends to stay behind in the gel. So those protons that are coming out of the gel are depleted in deuterium. I don't know how depleted they are, and I don't know if anybody has looked into that. I haven't found any studies that talk about that. My guess is that those protons that leave the gel are low in deuterium. So that's a perfect way for the body to reduce the deuterium exposure to the mitochondria by simply trapping the deuterium in the gel. And the gel everywhere in the body, not just lining the blood vessels, because most of the water in your body is gelled. And that has to do with the sulfate. The body puts these sulfates, attaches these sulfates to these heparin sulfate proteoglycans that make the gel. The sulfates maintain the gel in the water that lines all the blood vessels. And sulfate is also very badly disrupted by glyphosate. The entire sulfate system. I talk about that in my book. Glyphosate messes up many of the enzymes that are involved in managing sulfate. So you end up with deficiencies in sulfate lining the blood vessels, which means deficiencies in the gelled water, which means inadequate battery, which means not enough protons are being pushed out. And now you've got another deuterium problem sitting right there, right? Glyphosate disrupts the sulfate system. It also disrupts dehydrogenases as a class. And I've seen many papers. There was a paper on soil bacteria and showed that across the board, the soil bacteria had they were exposed to glyphosate, and it caused their levels of dehydrogenases to go down. And so there's NADH, dehydrogenase, is an enzyme in the mitochondria that takes the H off of NAD and puts it into the intramembrane space. As you can imagine, that is an incredibly important enzyme, NADH dehydrogenase. And it's been shown experimentally that it's suppressed by glyphosate in E. coli. And so that's pretty deadly. Also, succinate dehydrogenase is also a very important enzyme in the mitochondria that's also supplying these depleted protons to the ATPase pumps. It's suppressed by glyphosate. And malate dehydrogenase. There's many dehydrogenases, glucose 6-phosphate dehydrogenase. They've all been shown experimentally to be suppressed by glyphosate. And I know why, because dehydrogenases have a really beautiful glyphosate susceptibility motif. They have a pattern, GXGXXG, 3 glycines at the place where they bind phosphate. So that's exactly the same as the model with the EPSP synthase. So I think it makes sense that they would be suppressed by glyphosate. And if they are suppressed by glyphosate, it's going to cause a huge problem in the supply of deuterium-depleted protons to the ATPase pumps. It's very straightforward.
Yeah, so all roads lead back to glyphosate.
I think so.
Luckily, there seems to be at least a lot of trending towards the right direction of removing this product from our system. I mean, hopefully they don't bring up another product that's similar.
I know they're going to find something else that's going to have a whole different story.
Yeah.
But I want to talk about a particular dehydrogenase, which is it works on fats. And in fact, it works on fats like arachidonic acid, and so Dr. Mercola is really big on arachidonic acid. It's really awful. You got to avoid it. He's seed oils, he's talking about seed oils are bad. Arachidonic acid, I think, is not bad. I think it's because of the glyphosate. That's what's causing it to be bad. And the reason is because you can't digest it. When you have glyphosate exposure, I think it is disrupting an important enzyme that is involved in the process of digesting fats. It actually takes off. The fats have these, I told you these acetates are built, acetate is 2 carbons, and you have a bunch of 2 carbon sequences that line up to make a big long fatty acid like arachidonic acid. And when you digest it, when your mitochondria burn the fat, they love fat, actually. They like to have fat as a source of fuel. It's more efficient than glucose even. And they chop it off 2 at a time and make these acetates that are then metabolized. So you chew up the entire fat and make it disappear with this process. But if this enzyme is defective, you can't do that. So the arachidonic acid becomes undigestible. And then what happens is all these other enzymes start doing funny things to it, sticking in oxygen and making all these metabolites. There's like a million of the different fatty acid metabolites that are toxic. And there's huge papers with all these different complex names of all these things, that come out of arachidonic acid. They're just sticking oxygen in various places and modifying them. They're trying to extract the protons as best they can because the protons in the fats are really valuable. So the enzymes are trying to extract as many of those protons as they can without actually digesting it, because they can't digest it because that dehydrogenase is broken. And you see that with people who have defects in that enzyme. They have horrible conditions, lots and lots of problems, including autism. So the kids who have a defective version have symptoms of autism, it meaning a genetic mutation, which is a more severe situation because glyphosate is not going to get at every one of the molecules. It's going to only attack some of them. So you get kind of a partial version of this defect as a consequence of glyphosate exposure. But they're very picky eaters. Like they really have a lot of trouble with a lot of different foods. And you see that with the kids today. Many of the kids today are so picky about their food. It's ridiculous. You can't get them to eat, all these different they want to just have chicken nuggets every day,
Yeah. Yeah.
So I've really been impressed with the kids these days, how picky they are with their food. It's not the way it used to be. So it's picky food, and of course, and then horrible fatty liver disease. Fatty liver disease has been very clearly linked to glyphosate in multiple studies. It's very clear that it causes fatty liver disease, even at low doses. They've done that with mice and rats and humans. We have an epidemic in fatty liver disease, even like non-alcoholic fatty liver disease these days,
Yeah.
even among the kids. I mean, it's amazing. And that's because, I think, of not being able to digest the fats. And that's also why we have obesity, because you have to store the fats if you can't digest them, right? So I think it's very simple. That's how you end up with obesity. Just with this one dehydrogenase, it's an extremely important enzyme. And if it's not working properly, you're going to have all these symptoms.
Yeah. Wow. Okay. Wanted to ask you, so we mentioned you could do keto, you can do deuterium depletion, you can just clean your diet up, eat organic. That's always when you're ever starting anything, everyone wants to change they want to go to the gym, they want to do all these, buy new equipment, but it's always simple. Remove the toxin first, remove the thing that's poisoning you. And that is the first thing you should be doing.
Right. And eating whole foods, staying away from processed foods. Don't eat soy protein bars, candy bars. Eat foods that are natural. And lots of fruits and vegetables too, because they have a lot of useful polyphenols and flavonoids. Those are these complicated molecules. People think of fats, carbs, and protein as the sort of basic diet, but there are all these fancy molecules that the plants produce that are very healthy. And also eating a lot of fiber. Fiber turns out to be important because the microbes can turn it into butyrate. Mm-hmm. The microbes turn fiber into butyrate by making hydrogen gas. So that's how you get low deuterium nutrients for your colon, which is really important. So eating fiber is going to help you because the microbes break it down. But of course, if you're being poisoned by glyphosate, the microbes can't break down the fiber, and then it actually becomes, a problem because you can't digest it.
Yep. So key. What about anything else in terms of, I know we were talking, I think one of your talks, you were talking about spirulina or chlorella. You found
they produce these these fatty acids that are very low in deuterium. So they produce low deuterium fats. That's what makes them good, I think.
Is it both, or is it just spirulina?
I think both. I'll have to go back and check to make sure, but I think so.
Yeah, I can't remember which one exactly does, but okay. So yeah, spirulina. One of my favorite supplements is Energy Bits, and I know Catherine Arnston, who's the founder. She talks a lot about these good omega fats that you can get from spirulina and chlorella that people aren't even aware of. So, but I didn't realize there was a tie into deuterium, so I thought that was kind of neat.
Yes, low deuterium fats. I think that's really probably what makes it healthy. And I also like Epsom salt baths for the sulfate. People think of magnesium, Epsom salts, magnesium sulfate. The sulfate, both magnesium and the sulfate will soak through the skin and supply you with both magnesium and sulfate, both of which are important for your health.
Yeah, and that was something you were mentioning earlier, and I think there's a lot that has to do with sulfate and cholesterol, and I think...
Yeah, I like high cholesterol foods. We're so hung up on cholesterol, and people try to go on a low cholesterol diet, and I think that's ridiculous.
Yeah. And
cholesterol is actually a low deuterium nutrient. I was really shocked when I found out that cholesterol starts as 3 acetates. So acetate is this golden molecule that the gut microbes make out of carbon dioxide and hydrogen gas. So it's low in deuterium if it comes from the gut microbes. And then you have 3 acetate molecules that start the whole system that eventually makes cholesterol. I found that really fascinating. I've been looking at you have to look very carefully at the metabolic pathways to figure all this out. But when you start looking, you realize, oh my God, all these things, even the hormones and whatnot, and melatonin, they're all connected to low deuterium nutrient supply. And it becomes very elegant as you start to build the puzzle pieces together. It's really an elegant solution. I think the body obsesses on making sure that the mitochondria are not getting too much deuterium.
Yeah. What about any and I don't know how much you've gotten into this, but there's biohacks out there right now, like hydrogen water machines.
Oh, yeah, hydrogen water is very interesting. And I remember I heard about it many years ago. Someone gave a talk and they were really hyping hydrogen water. And I was just thinking I was really skeptical. I'm like, I can't figure out how
Yeah.
this can possibly
Like,
be
come on.
useful.
Yeah.
So, but I changed my mind once I learned about deuterium, because so hydrogen and water, typically you put something in there that makes hydrogen gas. So the thing is, it's not doing it enzymatically. Usually it's a chemical reaction, And so I don't know to what extent the low deuterium in the hydrogen gas that's produced by the microbes depends upon the enzyme itself versus just the natural properties of hydrogen for a tendency to stay in the liquid form. So it's
Yeah.
basically that the gas, by virtue of leaving the liquid, the deuterium has a much harder time doing that. So certainly the hydrogen gas will be low in deuterium compared to hydrogen that would be stuck onto different molecules like glucose, right? So I think that the reason why it's good, and I think it probably is good, is because it's low in deuterium. It actually supplies the hydrogen gas that's needed to make all these low deuterium nutrients in a way that doesn't involve the gut microbes. So it's sort of getting around the problem of the gut microbes not being able to make the hydrogen gas because they're being hurt by glyphosate.
Interesting. Yeah, I wonder if someone was supplementing with molecular hydrogen or the gas or drinking it regularly, if it would do enough to send the signaling to your body to then start healing on its own, and then the gut in turn would later heal or start making its own the hydrogen gas that it needs to create energy in a low deuterium
Right. I
state
mean,
as well.
if you're able to supply hydrogen gas in a different way besides the way the microbes do it, and if that hydrogen gas is also depleted in deuterium, which I'm not sure if it would be as depleted, because often the enzymes are really skilled at selecting hydrogen over deuterium. There are many, in fact, the dehydrogenases, most of the dehydrogenases are able to, if they're trying to pull a hydrogen off, but it's actually a deuterium, they kind of don't like it. They'll favor a version of that molecule that has hydrogen rather than deuterium. They don't work as well with deuterium, which is good because then they don't tend to put deuterium onto the NAD. They put hydrogen there. They're more, even they have less deuterium than what the source from which they built the NAD. I'm having a hard time figuring out how to say this.
Yeah.
But they can make it even better. If you've got something here that happens to have a deuterium on it, they won't choose that molecule. They'll go get another one that doesn't have deuterium to do to supply the H. So they're good at selecting hydrogen over deuterium. They have a very fancy arrangement that allows like a water wire to hand over the hydrogen, and so the deuterium doesn't travel down the wire nearly as well as hydrogen does. They have a very tricky schema to avoid deuterium beyond just choosing something that doesn't have a lot of deuterium in it to begin with as their source. They can do even better than that. These
Wow.
dehydrogenases, they're really wonderful enzymes, and they get wrecked by glyphosate.
Wow. Amazing stuff. I want to wrap things up, but I wanted to ask you any exciting projects or anything that we can expect from you that you're working on right now?
I'm working on deuterium. I'm trying to write papers on deuterium, and I'm having a lot of fun. I'm studying cancer, actually, really seriously studying cancer with respect to deuterium, and I think that's a really interesting story. Cancer cells, when you grow them in culture, they've done experiments where they expose them to heavy water, like water that has twice as much deuterium as normal, and water that has half as much deuterium as normal, and then normal water, sort of 3 different groups of cancer cells being grown. And the interesting thing is that the ones that have more deuterium, they do well. They multiply, they grow. Less deuterium, they get sick, they die. They don't thrive. And whereas regular cells have the opposite effect, they do better on low deuterium and less well on high deuterium. What this tells me, I suspect, is that cancer cells have a purpose in life, which is to try to trap the deuterium and supply the rest of the body with deuterium depleted nutrients. This is the idea that I'm working on. I really am enjoying it. It's I have to read a lot of papers on cancer. Cancer cells have a unique metabolism that's very different from the way normal cells behave. But it looks to me like it makes a lot of sense to me that what they're trying to do is to hoard the deuterium and then feed the body with, especially feed the immune cells that are hanging around the cancer cells, provide them with deuterium depleted nutrients so that they can heal, so that they can clear the cancer. So I think it's an interesting view of cancer that says they have a purpose that's a positive role in the body.
Interesting. Wow. Yeah. There's no accident. I think that our body created different systems for different times. And I think when we're out of balance with nature, our lifestyle, our environment, our food, toxicities, then things go haywire. The body gets the wrong message, and that's when you see the uptick of cancer, right?
Yeah, yeah. I think there's an underlying purpose to help heal the immune cells so they can do their job, by virtue of the cancer supplying them with, for example, lactate, which is a low deuterium nutrient. Cancer cells make tons of lactate, and then they supply it to the body. So it's a really unique point of view on cancer, that it has a positive role.
Yeah.
And if you can just feed the cancer and nourish it, maybe it'll go away, because eventually it'll be able to fix the immune cells so they can clear it, you know?
Uh-huh. Wow. Wow, that's amazing. Okay, really cool stuff. Last but not least, where can people find you if maybe you don't want them to find you, but I know I know you live a somewhat of a private life, but if people want to just connect with you, or they want to learn more about your papers and just some of the things that you're up to, where can they find all that great work?
Yeah, I mean, I have a webpage, stephanieseneff.net. I have done a lot of interviews, so if you search my name, if you can remember the word Seneff, Seneff, you can find a lot of interviews and presentations and whatnot on the web.
Dr. Stephanie Seneff, thanks for being on the show again. Appreciate you.
Thank you so much. My pleasure.